Okay, this video is about right triangles and trigonometric functions. So here what I've done is I've drawn a right triangle and I have this angle theta right here. And so here's the angle right here, and I've labeled opposite that angle, the side opposite, I call it opposite, and then next to it is adjacent, and then here's the hypotenuse of the right triangle. And through this, we can define sine and cosine and tangent. Now, under this construction here, theta, because it's an angle in a triangle, has to be greater than 0 degrees and less than 90 degrees. So this is a way to define sine, cosine, and tangent, but there's some limitations, and the unit circle expands on this idea, but it is consistent with the unit circle definition. Tangent theta, okay, so sine is opposite over hypotenuse, so it's a ratio opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent theta is opposite over adjacent. All right, now what's going on is this is a ratio of sides, and what happens is it's sort of what the foundation is that of all of this is that regardless of whether I have this triangle sort of big or I don't it's relative to whatever you think big is, but if I have the same angle here, but this is smaller, say I don't know if that's exact, but maybe the sides are half as long as the one I have on the left. These triangles are similar, and similar triangles have proportional sides, which means that these proportions of opposite to hypotenuse, adjacent to hypotenuse, opposite to adjacent are the same. So similar triangles means that they have the same shape but different size. And so these ratios remain constant for this angle here. So since this angle is in both cases we have 90 degree angles, and so we already have that as 90, and then if you have this angle theta, this other angle is determined because they all have to add up in 180 degrees. All the angles add 180 degrees. There's a mnemonic, which is mnemonic is a way to remember something. It doesn't mean it has any necessary logic to it, but and it's also sort of a weird word to spell. Actually, I don't even try to do that right now. But people do this so katoa. I just can't even remember how I learned this. I mean, whether I did, I don't really think I did. I don't think I did so katoa. But it's oops. Okay, yeah. So I'm just thinking about my past and whether I remember this. Okay, this is sine. It's opposite over hypotenuse. This is cosine adjacent over hypotenuse. This is tan is opposite over adjacent. Anyway, so katoa. Let's do a little example. I'm going to write this right triangle here, and one thing to keep in mind is that these numbers aren't entirely just made up. I mean, they are, but they have to follow the guidelines of a right triangle in that they have to satisfy the Pythagorean theorem. So a squared plus b squared equals c squared. And we see that that does in this case. So find a, let's find cosine, let's call this theta. Cosine theta, b, sine theta, c, tan theta. So it's adjacent over hypotenuse, opposite over hypotenuse, opposite over adjacent. Okay, and then we define, well, I'm just going to say it's a definition. It could be an identity, but anyway, I'm going to say that cosecant theta is 1 over sine theta. Secant theta is 1 over cosine theta. and cotangent theta is equal to 1 over tan theta. Some people say, well, no, I think probably the book that I'm using is OpenStack's book. Maybe wouldn't say they say this is an identity, but you could define these functions this way. But if that's true, this is hypotenuse over opposite, and this is hypotenuse. Cosecant would be hypotenuse over adjacent, and cotangent would be adjacent over opposite.